Today, we are going to discuss the world of self-improving autonomous underwater manipulation. That sounds like a lot, right? And it is, but it's also one of the most fascinating developments in robotics. We're exploring a research paper that introduces us to AquaBot, a system where robots are not only able to perform tasks underwater but are constantly learning and improving at them. And that's no easy feat, especially in an environment as unpredictable as the underwater world, with complex fluid dynamics and ever-changing conditions. Imagine trying to navigate those challenges with precision. That's where AquaBot stands out. AquaBot leverages an affordable off-the-shelf underwater drone called the QYSC-A5 Fish Vivo, costing around $1,600, which is much more accessible than custom-built alternatives. This drone comes equipped with two cameras, one with ultra-low latency for real-time control, and a gripper, all connected by a tether for control and data transfer. The researchers chose this equipment deliberately, emphasizing affordability without compromising functionality. It's impressive to think about all the engineering that goes into making this possible without breaking the bank, especially considering the complexities of underwater manipulation. But how does AquaBot actually learn underwater? Well, it all starts with humans teaching it by example. Researchers use an Xbox controller to operate the drone manually, showing it how to perform tasks like grasping objects, while AquaBot records these demonstrations. This method, known as behavior cloning, is akin to teaching a pet new tricks by showing it the desired behavior. But here's the exciting part. AquaBot doesn't stop at imitation. It continues to practice on its own, refining its movements, optimizing its efficiency, and learning to complete tasks faster, all through self-learning techniques. It's like the robot is having aha moments underwater, continuously improving with each attempt. This self-learning ability relies on something called a surrogate model, which acts like a virtual simulation within the robot's brain. Before attempting a task in real life, AquaBot can test out possible actions in the simulated environment, allowing it to anticipate and plan movements more effectively. Imagine it's trying to grab an object underwater. By testing different approaches in its surrogate model, AquaBot avoids the trial-and-error process that could lead to failure in the real world. This capability transforms it from a reactive robot into a predictive one, and the potential applications are immense. To validate its self-learning, researchers put AquaBot through 3 challenging tests: object grasping, trash sorting, and rescue retrieval. In the object grasping task, it learned to control its speed and movements for precise handling, mastering underwater finesse. Trash sorting demonstrated its potential for environmental impact, envisioning future robots autonomously cleaning up our oceans. And the rescue retrieval task pushed AquaBot's limits. It successfully retrieved a 6.8-kilogram humanoid object, more massive than its own weight, highlighting its strength and adaptability. In just 120 trials, AquaBot even outperformed human operators in speed by an impressive 41%. The future of AquaBot and similar robots points toward applications that could significantly benefit our environment and industries. Picture a fleet of these self-improving, solar-powered robots, learning from each other and autonomously adapting to various underwater conditions to clean up oceans, inspect underwater infrastructure, and monitor marine ecosystems. Yet, challenges like reliable navigation and sustainable energy sources still remain. Researchers are exploring sonar systems, advanced image processing, and even harnessing energy from ocean currents to ensure these robots can work efficiently over long periods. This incredible technology is not about replacing humans. It's about working alongside us to accomplish more. Underwater environments are complex, and even with all their intelligence, robots still face limitations. Tasks that require sensitivity, complex decision-making, or understanding fragile ecosystems may always need human involvement. Yet, by combining human adaptability with robotic precision, we are looking at a future where we can tackle once-impossible tasks underwater. This collaboration between humans and machines could revolutionize fields like conservation, infrastructure maintenance, and marine research. Thanks for joining us on this exploration into the future of underwater robotics. This is just the beginning. Until next time. Thanks so much for watching. Be sure to like this video and subscribe to our channel. See you next time.